before continuing further, let me once again explain you the universal set, the concept by reading out the definition for you. The universal set, as I have explained you, is set which contain all other element of all other sets, and the other sets which elements are present in the universal set, they are known as subset. So according to the definition, a suitably non-empty set of which all sets under consideration are subsets of that set is called the universal set. So let me explain you in a detailed way by giving you this example, which is already there in your textbook. Now A is a set such that it has X element, and X is what? X is student in 9th A class, right? And then again there is another set B which consists of Y element. What are Y? Y is a student in 9th B class. There is a third set, C set, which contains Z elements. And what is Z? Z is a student in 9th C class. Then the last set, U. U is a set which contains U element, and this U is what? U is student of standard 9th of your school. So now when I talk about U, U is a student of standard 9th of your school. Means here I am considering all the students who are in 9th grade, right? So this is what? It contains all the students. That means of division A, division B and division C. So this is a universal set. And these elements, these are elements, these students I am taking from 9th grade only A division. These students also I am taking from 9th grade, that is from B division, and this is C. So I can write this as U is a universal set. Why it's universal set? Because it contains all the elements which are there in A, B and C. So I can show the relation like this. A is subset of U. B is also subset of U. And C is also subset of U. Right? Same way, I'll explain you the another example. As you know the numbers. This is a number line and here the numbers are given. Right? Now in the number line, all the real numbers are there. Right? And what are real numbers? Real numbers are contain both rational and irrational number. Rational number we always denote by Q. Okay, and this another irrational number. Numbers. Again, what are rational number? Rational number contain integers. And integers contain all the numbers, negative, positive and 0. So this contain whole number. Further, whole number contains natural numbers and natural number contain odd and even number. Right? Now here also we can show the relation by using the subset. Here universal set. Universal set is a real number set. Right? Now this is a universal set. Then we know the integers. Integer is the subset of real number. Integer means all this number. It contains all this number. Then comes the whole number. Whole number is subset of integer. And then the natural number. Natural number are subset of whole number. Then comes the prime number, odd numbers and even numbers. These numbers are subset of natural number. As prime number starts from 0, prime number starts from 2 and odd number starts from 1, 3, 5, 7, which are included in natural number, and even number from 0, 2, 4, 6. So these all are subset of natural number. Natural number is subset of whole number. Whole number is subset of integers, and integer is subset of rational number, or you can also say a real number. So by this, I think the concept of universal set and subset is clear. Let's further be clear by doing the exercise. So children, let's move further and I'll explain you now the exercise 1.3 given in your textbook. Now in this, the first question, they have given the different sets. Set A, it considers the set of all residents in Mumbai. Then set B is given, which consists of all the residents in Bhopal. There is a C set which consists all the residents in Maharashtra. And then there is a D set which consists all the residents in India. E is the set of all residents in Madhya Pradesh. Now, by looking at it or observing this, you'll come to know this is a state, this is a city, both Maharashtra is a state and Madhya Pradesh is also state, and these all are located in India. So India consists of all these states. So here what will be the universal set? The universal set will be the set of all residents in India, as these elements, the elements in Mumbai, Bhopal, Maharashtra, Madhya Pradesh, as they reside in India or they are in India, so all the elements are in India. So India is a superset, or you can call it as a universal set, and all these sets are subset of India. So let's see what the question has been asked over here. Now the first question is like, show the relation of set A and C. Now let's see what the A set consists of. The set A has the set of all residents in Mumbai, and C the set of residents in Maharashtra. So as I know, Mumbai is in Maharashtra. So set C is what? C is a superset, and that is, so C, I can say that set A is a subset of C. As the element of set A, Maharashtra consists all this element. If the set of residents of Mumbai are in Maharashtra, so A is a subset of set C, and this is the way you have to write the answer. The next, they have asked the relation between set E and D. Again we'll see what is there in E. E is the set of all residents in Madhya Pradesh. And D, what is D? D is the set of all residents in India. As I told you, India is a universal set. So it consists of all the elements which are in E set. So again here I can say that set E is subset of set D. Right? As D is the set of all residents in India. Now the third question which they have asked is, which is the universal set? As we already know, India is the resident of all India. The set of all resident in India means it consists of all the elements which other sets have. So here the set D is a universal set. Right? Now we'll move to the second question. Let A is a set which consists of three elements, A, B and C small. And then there is a B set which consists of only one element A. We can say that it is a singleton set. As you know, a set contain only one element is known as singleton. Now C is another set which consists of A and B. Now by observing this, you can make out A is the element which B consists of, is also present in this set, capital A set. And then here C, the element of C are also present in this. So by observing this, I can say that A is a universal set, B is a subset of A, C is also subset of A. Right? Now here they have asked proper subset of A. So the proper subset of A is set B is subset of A and also set C is subset of A. This is the symbol which you have to use for subset, right? Now the next question, which set is the superset of C? Now which is the superset of C? Now C consists of A and B, two elements. We'll see in B set. Is there B present in this set? No. So B can't be the superset of C. We have to see that a set which consists of all this, then only we can say a subset. So now we'll consider set A. Here in set A, B, C. So A, B are present in this. So set A is superset of C. Right? Now the third question which they have asked to draw a Venn diagram showing the relation of the sets. Now here A set is given which consists of two elements, just 2 and 4. Now B is a set which consists X elements. Now what is X? They have given X in the set builder form. Here they have given X are such element which you can show the 2 raised to n. And what is n? N is less than 5. And this n belongs to m. Small n belongs to capital. And here it shows it denotes natural number. So here n is a natural number. It is less than 5. So this set in a listing form I can write B equals to what? B equals to n is what they have said, natural number. So that will be n less than 5. So it will be 2 raised to 1 as the natural number starts from 1. Then 2 raised to 2, 2 raised to 3, 2 raised to 4. Right? Now what it is, I can write like this. 2 raised to 1. Any number raised to 1 is a same number. So it will be 2 itself. 2 raised to 2, that is square of 2, 4. 2 cube is 8 and 2 raised to 4 is 16. So now we got the exact element which the set B is having. So set B is having 2, 4, 8 and 16. Now there is another set C which consists of all even natural number less than and equal to 16. As I have explained you, whenever less than and equal to is there, this 16 is also included in this. This set again I can write in listing form. In listing form, it is an even number. You can start 2, 4, 5, even number 6, 8, 10, then 12, then 14, and here it is equal to 16, so 16 is also there. Right? Now this you have to show by drawing the Venn diagram. Now Venn diagram is always represented with a rectangle. So I'll draw this Venn diagram. As you know, set C is having all the elements which is in set B and A. So set C is a universal set. So this big rectangle, I'll give the name C. Now I can write these numbers like this. It is immaterial. Wherever you can write it, it's not necessary you should write number wise. So 2, 4, 6, 8, then 10 is there, 14 is there, 16 is there, right? So 2, 4, 6, 8, 10, 12 I have not written, 12 I will write, 12, 14 and 16. So these are the elements which are in C. Now but I have to show A also. This set A, it has the elements which are already present in this set C. So I can represent here. This is A and A is a subset of C, as the C consists of elements which are already present in A. Now then there is another set B which consists of what? 2, 4, 8, 16. So I can write this. B is a set where it consists of 2, 4, 2 is there, 4 is there, 8 and 16. So I'll draw like this. This I can move here. 6 and this is B set. This 10 I can. So now I can give this name as B. So from this Venn diagram, it is clear that set C is a universal set, as it consists of all the elements which are there in set A and B. So this set is having 2, that is also there. So I can show this in a Venn diagram by drawing a circle. These 2 elements are there in A, so I give the name A, and then this element in B are 2, 4, 8, 16. So I can draw another circle and give the name B. So this is also the relation between them. C is a universal set, and A is subset of C. B is also subset of C. Now let's move on to the fourth set.
No more spending your energy and money on coaching classes, or missing classes for rain, for rally, and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
Now children, in your exercise 1.3, the fourth sum is asked, it has been asked to prove that A is subset of B and B is subset of C. If this A is subset of B and B is subset of C, then A is also subset of C. Now to prove this, the hint is already given in the textbook. Now according to that, here is the answer. X is an element which belongs to A. Suppose this is an element which belongs to A. So as A is a subset of B, so X belongs to B also. As B is subset of C, so X belongs to C also. So that shows us that every element of the set A is the element of set C also, and that's the reason we can say that A is subset and equal to C. Once again I'll explain you this. To prove this, we have to suppose that X is the element which belongs to A, and A is subset and equal to B. Therefore the X also belongs to B. As B is subset and equal to C, X belongs to C also. And from this only we can make out that the elements which contain in A are also the element in the set C. So it is proved that set A is subset and equal to C. The next question is asked, fifth question, that if X is a set which consists of number 1, 2, 3. There are 3 elements in this set, and they have asked you to give all possible subset of X. So we can use, what is subset? Subset is a set which consists the element which are present in universal set. So here X is a universal set. You can use only the element which are present in this set. So Here only 3 elements is there. So I can take a null set. As you know, null set is a subset of all the sets. So I can give null set as first example. The next set I can take only one element. 1, so this is subset of this, right? Because 1 is present here also. Then another set you can give, this is also the possibility, 2, number 2, as this is also present in here. So this is also a subset of this set X. Then you can take number 3, this is also subset of X set X. You can take any two number, 1, 2, 2, 3 or 1, 3. These are the elements which are present in this. So all these sets are subset of this set. So these are all the possibility by which you can show that the subsets of set X as the element which are in subset are also present in the universal set, that is set X. Hope so now the concept of universal set and subset is clear by now. Let's move to the other terms. Now children, let me explain you some other terms related to the chapter set. Now when we talk about set, there are different sets and sometimes the two sets have the common, as we have seen in subset and universal set. So when a set has something in common, two sets have something in common, that is known as intersection. Now in intersection we consider only common elements. Now I'll explain you this with a given example over here. Now here A is a set given which consists of all the even number or multiples of 2 there is till 6. So multiple of 2's are 2, 4, 6, 8, 10 and 12. That is less than 16. Now B is a set which consists the multiple of 3, right? So here it is 3, 6, 9, 12, 18. Then C is a set which consists of 6 and 12, 2 elements. Now what you can observe here, see here in the set A and B, when I consider both the set, what I'll find here number 6 is present in both the set, right? And the number 12 is also common. Now this number 6 and 12 is here in the set C. So I can call this set C is the intersection of A and B. Intersection of set is always denoted by this sign. And when I say the intersection of, I'll ask A and B, set A and B, intersection of B, then what I'll write in this set, all the common element which are there in the set A and B. Here we find that 6 and 12 is common. So this will be the intersection of set A and B. Now where are these elements? These elements are given in C. So we can say that C is a set, it is also intersection of A and B. Or you can just give, instead of writing this, C is intersection of A and B set. Now from this it is clear that intersection of A and B, it's a consist of element X, and X belongs to set A also and X belongs to set B also. So here in this example we find that 6 belongs to set A also and 12 also belongs to set A, as well as they belongs to set A, B also. So 6 is present in set B also. Now the other thing which is clear from this is, if the element belongs to the intersection of A and B, like 6 and 12, they will also belong to set A and set B. So this I can put by this symbol. Once again I'll explain you. If X or element which belongs to the intersection of two sets, then it will belong to both the sets, set A as well as set B, right? Now here again with this example it is clear that now X and 12 belongs to the intersection set, right? So X and B, this elements also belongs to A and it also belongs to B. So if X, or there is some element, suppose I'll take 7. Now 7 does not belong to A, and so it will not belong to the intersection also. So it will not belong to the intersection of A with the B set, right? And then it will also not present in set A and B. Here in this you can find out that 7 is not present in set A, and it is also not present in set B. Now the next term, which is disjoint set. Disjoint set means not a single element is common. Not a single element is in common, or nothing is common. That means the elements are not present in both the set. So now here again one example is there, set X. Here the set X, the numbers are even numbered, less than 10. That is 2, 4, 6, 8. And there is a set Y which consists of odd number less than 10. That is 1, 3, 5, 7. Now if I want the intersection of this, do you find any number in common? No, not a single element is common in both the set. So this set does not consist of any common. So when I talk about the intersection of set A with B, so what I'll get? I'll get null set, as not a single element is common in both the set. So disjoint set is always a null set. Now let us move to the property of intersection of sets. Now the first property, which is commutative property. When set A and the intersection of set A with B is equal to the intersection of set B with A, it is always equal. This I'll be explaining you further when we'll do the exercise. Now the second property, which is associative property. Here when the intersection of A set is with the intersection of set B and intersection of C, I'll take this together and then I'll make the intersection with set A. This will be always equal. If I'll take it, doesn't make any difference if this I have taken before, the set A and B, the intersection of A and B I have taken before together, and then I find out the intersection of C. So it does not make any difference. As you have learned this property in addition and subtraction also, in multiplication doesn't make any difference. So same way here in sets also this property is there, which is always equal. It doesn't make any difference if you take this two before it, or you'll take this two together, B and C set. The next property is third, the intersection of set A with B is always a subset or equal to A, and that is the intersection of A set with A intersection B is also subset and equal to B. So this is the third property. The next fourth property they have given, if set A is subset of another set B or subset and equal to P, then B is also, there is another set which is subset of P, equal and subset of P, that is subset and equal to P. Then what does it mean? That A intersection B, as they have the common element, that is also subset and equal to P. Why? Because both are, set A is also subset of P and set B is also subset and equal to P. So that's the reason the intersection of set, both the set A and B is also subset and equal to set P. The next property is, if set A is subset and equal to B, then the intersection of both the set A intersection B is equal to A, right? And if B is subset or equal to A, then the intersection of A set with B will be equal to B. The next property, that is the last property of this intersection of set, that is sixth property. Whenever any set is given and asked about the intersection with null set, the answer will be null set. And the A intersection A will always give you the same set, set A. So hope so you are clear with the property of intersection of set, and I'll be explaining you further. You will be more clear while doing the exercise. Now children, let's move to the another topic, that is union of sets. Now what does union means? Union means all together. If there are two sets, like set of numbers, all the odd numbers below 10, that is less than 10, and all the even number below 10. If I put these two sets, it will be a disjoint set as they don't have anything in common. But when I'll say union, means I'll put all the elements together. There will be a next another set, let the set be C, which will consist all the elements which are present in A and B. That is all the element, all the number of odd number and the even number together. So union means what? Putting the element together. The only thing you have to remember in this is the element should not repeat. So whatever is common in both the sets, that will not repeat. Only once you have to write. Now let us take the example of union of set. Here A is a set given where the numbers are from 1 to 5, right? And the B is another set which consists of number 3, 5, 7 and 9. And when I'll ask you, give the union of these two sets A and B, so it will contain all the elements which are present in set A and also present in set B. So I will take 1, 2, 3 is in both the sets, so only once I'll write 3, then 4 I'll write, then 5 is also in both the set common, so I'll write 5 only once, and then I will include this 7 and 9 also. So here they have given you C is a set which consists of 1, 2, 3, 4, 5, 7, 9. So what I can make out from this, that C is a set which is equal to the union of set A and B. Union is always denoted by this symbol. So when I'll write here A union B, set of A union B, this is equal to set C, as C consists of all the numbers or elements which are present in both the set. Thus it is clear, if the union of set A and B is given, it will consist of elements such that here it is given X. What is X? Such that X belongs to A. Means that element will belong to A set A and it will also, or it belongs to B. Means it will come together. Right? Now if any element Y, suppose Y belongs to A union B, then Y belongs to both the sets, set A or set B. And if the Y element does not belong to A union B, then this Y will also not belong. It will not belong to set A and also it will not belong to set B. Now these things, the union and the intersection which I have explained you, we can show it in the form of Venn diagram. Here when I will talk of union means I will be taking together. Here it is 1, I will put, because in A set, what numbers are there? 1, 2, 3, 3 is common in both. So whichever is common, I'll put it here. 3 is common and the another is 5 is common. Sorry, this is known as actually intersection. The element which are common, that is intersection. So at the other element which are remaining, that is in A, 1, 2, 3, 4, 5. So 1 I have written, 2, 3, 4 will come here, 5 is already there. And set B is having 3 and 5 I have written. So 7 and 9 I will put here. So when I will ask A union B, you have to shade it, you have to shade completely. This will give you A union B. That means all the element which are present in both the set. Now when I'll ask only intersection A intersection B, then I will shade only this part which is common to both. 3 and 5 are common. 7 is not in set A. 9 is also not in set A. It is only in set B. Now the number which are not in set B, that is 1, 2 and 4. And when it is asked shade the intersection part, as I have told you, intersection means only the common number. So here the common is 3 and 5 and this is the part of intersection. So to show it in a Venn diagram, I have already explained you. This is the A union B, means I am considering all the element of both the set A and B. And when I will talk about the intersection, I will be dealing only with the common element which are present in both the set A and B. Now I will take another example, that is C is a set which consists of 3 elements 1, 2 and 3, and D is a set which consists of 4, 5, 6. Now let's put this number over here. Now this is C is 1, 2, 3 and D is what? 4, 5 and 6. Now when I talk about the union, if this is C and this is D, so I'll talk about A union D. So I'll be taking all the elements, means I'll take this elements and also this element. And how I will write that set? I will write like this. 1 is there, 2 is there, 3 is there, 4 is there, 5 is there and 6 is there. Here what you can see that your set C and D are disjoint set. So they don't have anything in common. So if I'll ask you, give the intersection C, sorry it is C over here. If I'll ask you, give the intersection of set C and D, do you find anything in common over there? No, there is not a single element common in both the sets. So it will be a null set, as both the sets are disjoint set. So hope it's clear with you what is union and intersection. This both the thing you can show it by Venn diagram as I've explained you. Now we'll move to the properties of union of sets. Now the first property of union of set is the union of set A and B will be always equal to the union of set B and A. It doesn't make difference if we take A first or B. It's immaterial. Now the second property is, if I take set union of A and this together, B union C, the element which are present in this union, that along with A, then this will be equal to, always equal to A union B set, then the union of C. This is known as associative property. The first property is known as a commutative property. The third property is, if A is subset and equal to A union B, then B is also subset and equal to A union B. This again I'll explain. If A is subset and equal to A union B, then B is also subset and equal to A union B. The next property is fourth one. If A is a subset and equal to set B, then A union B is equal to B, and if B is subset and equal to A, then A union B will be equal to A. And the fifth property is A union null set is always equal to A, as null set does not have any element, and A union A is always equal to set A. Let's move to the another term now, as we have already completed this properties of union set.